In this video today, I'm going to show you my SAR ADC project. This is the complete version. The SAR ADC is just an analog to digital converter using successive approximation. So I'm going to get right into it and show you my prototype. Like the other videos in this series for the SAR ADC, this project was originally designed by Mitsuru Yamada. You can check out his Hackaday.io project in the description. This is the working prototype of the SAR ADC. As you can see, when I turn the potentiometer, it's producing an analog signal, and this analog signal is being converted into a digital binary 7-bit number, as you can see represented by the LEDs at the bottom. If you are like me when I first started this project, you're probably confused about what the output actually means. So it's actually very simple. Let's start with the values that we do know. So we do know 0 volts is equal to 0 on the binary output, and 5 volts is equal to 127. We also know that it's linear, so whatever we do to 127 to get to 5, we just need to do to the output value to get our voltage. So first, we can start off by dividing 127 by 5, which gives us 25.4. Then, if we divide our x value by 25.4, that will give us our voltage. Pretty basic. So, half of 127 is 63. So let's test this. If we get 63 on the output, we should get approximately 2.5. And as you can see here, approximately 2.5. If I do 63 divided by 25.4, you get approximately 2.5. The ADC part of the SAR ADC is straightforward. It's an analog to digital converter. However, the SAR part can be pretty confusing. Successive approximation register is the full name. But it's pretty interesting when you break it down. So we start off with this comparator right here. This comparator will compare our analog value to some test value. Now this test value is generated with this whole process right here. A binary number is generated, and then it is turned into an analog value through this DAC right here, this digital to analog converter. It'll come into here. Our potentiometer will come into here, and it will test them against each other. If it realizes that its test value is less than our analog input, it will say, oh, I need to adjust my test value, and it will make it greater. It does this for all 7 bits until we get our final 7-bit output right here, which should approximately represent our analog input. And that sums up the SAR ADC project. The SAR part is really cool. I like to think about it as like a mini machine learning model in hardware, which is really cool to me. And if you found this project really interesting, and especially if you want to find out more, don't be afraid to go on out and check Mitsuru Yamada's Hackaday.io project. It's in the description.